Hello friends, and welcome back to Dana's Learning Lab. Today we are going to be discussing something in physics relating to magnetism. I'm going to teach you how to determine the direction of the magnetic force on a charge. Now, you may have heard of something called the right-hand rule, which can be helpful in determining the direction of the force. Now, this is a difficult concept for many people, including me. The right-hand rule was difficult for me to grasp because it was hard to orient my hand in all the directions and make sure I got the direction correct. So I've come up with an alternate right-hand rule that I have titled the right pen rule. Now, the question says, what is the direction of the magnetic force on these positive charges? Now you have to notice if it's positive or negative will make a difference, so it is important to notice, and we will talk about the difference later. I just want to indicate that a circle or a solid dot indicates that it is pointing out of the page. If you imagine an arrow, imagine the arrow pointing towards you, you see the arrowhead only as a dot. Now, an X will indicate that is going into the page, because when the arrow is going into the page, you will see the tail feathers. Now we will begin with number 1. So first, what I'll do is put my pen in the direction of the velocity. The velocity is pointing left. Now, the magnetic field is pointing down. Therefore, I'll place them at the corners. I want to put my pens together just as they are on the page. Now, an important concept that we need to know is V cross B. Always memorize that. Velocity crossing over to field, V cross B. Now, in this first one, we're going to cross over V to B. This indicates a counterclockwise pattern. Now, since it is going counterclockwise, as I've written in the board, it will be positive. This may seem counterintuitive, but you have to remember that counterclockwise indicates positive and clockwise indicates negative. Now, since my velocity going counterclockwise towards the field, it'll be positive. Now, if we indicate that it is positive, the only places it can go is to the right, up, or out of the page towards you. Now, in this case, we already have the velocity going to the right, so the force cannot go left because then they'll cancel each other out. The field is going down, so the force cannot go up because again, they will cancel out. The only place that it can go is out of the page towards you. So, as I've indicated here, the force is pointing out of the page towards you, like so. Now, if we go on to number 2, we can notice that the velocity is pointing out of the page towards you, and the field is pointing left. So I will place them at the corners of each other, velocity and field. Now, when I do V cross B, if I look at it from a bird's eye view, V will cross over to B in a clockwise fashion. Now, since it's clockwise, it is negative. And the only place it can go is left, down, or into the page. In this case, we already have the field going left, so it cannot go there. We have the velocity pointing out of the page, so it cannot go into the page. And we have the only place that it can go is down. So it's already pointing left and out of the page, so the force has to point down, as I have indicated here. Now, for this third one, if you'd like to try it on your own, please pause the video. But I will go ahead and do that, explaining again that the X is into the page. Now, we have our velocity pointing into the page, and then we have our field pointing up, placing them at the corners of each other. Now, you don't want to change the orientation because that can change the direction. So you want to keep it just as it is on the page. So I have my velocity pointing towards me and my field pointing up. Now, when I do V cross B, I will notice that it is going in a clockwise fashion, up to 12, clockwise fashion. Now, that indicates negative, as we have said. It can either go left into the page or down. But we already have one going into the page, so it cannot go there. We have one going up, so it cannot go down. The only place that it can go is to the left. So it is clockwise, negative, and it's gonna go left, which makes sense here. Because if you were doing this, you'd notice that if you put it out of the page, they'd cancel, and you can't go down, they'd cancel, so it has to go left if it's negative. So I will write that here. So, overall, it is just important to memorize counterclockwise is positive and clockwise is negative, and that a circle is out of the page and an X is into the page. Now, it is very important to practice. You can use this along with the right hand rule, but I noticed that this right pen rule works every single time for me. And so it is important just to keep the pens oriented and match up colors so you know which way the velocity or the field or the force is going. And you can also work backwards in this. For example, if you want to figure out the direction of the field, you just place the pens where these are supposed to go and then figure out the direction of the field. And another thing I would like to add is the formula for the force on a charge. So that would be magnetic force equals Q, which is the charge. Now that's going to be an absolute value. V, velocity. V, field. Sine theta. Now this is the sine theta is the angle between velocity and field. In all of these examples, it has been 90 degrees. So when you place them at an angle, all of them have been 90 degrees so far. And so the sine of 90 is equal to 1. So in all of these examples, if you were given numbers for field and velocity, you would just multiply those by the charge of the proton, and you can just put sine theta as 1, and you'd have the magnitude of the force. Now, it is important to note, as I said earlier, that it is important if it's a positive or a negative charge. In all of these examples, it was a positive charge, so we'd leave the force as is. Now, if it were a negative charge, an electron, then the force would point in the opposite direction for all of these examples. Now, since this one is going out of the page, if it was an electron, the force would be pointing into the page. This one is pointing down. If it was an electron, it'd be pointing up. And for number 3, it is pointing to the left. If it was an electron, it'd be pointing right. So you get the idea. It's just the opposite. Overall, it's just important to keep up with the directions, and then this is the formula if you need to find the magnitude along with the direction. And I hope this helps you understand the direction of the magnetic force. And if you have any other topics you would like me to discuss, please let me know in the comments below. And thank you so much for watching. See you next time.